This is a verbal walkthrough of the Power Unit Magnets module designing a maglev system. Make sure to download this file into Notability. Then read the book Hikaru's Toy Troubles to understand the need to design a maglev system. You will need to 1. Describe how Hikaru used the design process. 2. Imagine what materials you can use to create a track and vehicle to test your maglev system. 3. Draw a diagram of your maglev system. 4. Get feedback from your classmates. 5. Build your maglev system. And 6. Reflect on if there are any areas you could have improved on. All of this evidence should be seen through your work in Notability. The engineering design process. 5 steps for engineering design. Ask, what's the problem? What have others done? What are the constraints? Imagine, what could be some solutions? Brainstorm ideas and choose the best one. Plan, draw a diagram, and make a list of materials you'll need. Create, follow your plan, and create it. Then test it out. Improve, make your design even better. Then test it out again. Hikaru and the engineering design process. Directions. In the boxes below, write or draw a picture explaining how Hikaru completed each step of the engineering design process. On the left are the steps of the engineering design process. Ask, imagine, plan, create, and improve. On the right, how did Hikaru complete this step? Designing a maglev system. Engineering design process. Ask. 1. List 2 properties of magnets that will be important for your maglev system and explain why the properties are important. Property 1 is, and this property is important because. Property 2 is, and this property is important because. 2. What are the 2 parts of the maglev system that you are designing? 3. What will your maglev system transport? 4. How will you know if your maglev system is successful? Designing a maglev system engineering design process. Imagine, page 1. Directions. In the box below and on the next page, brainstorm 2 different maglev transportation system designs. Be sure to include what the maglev vehicle will look like and what materials you will use, what the maglev track will look like and what materials you will use, where you will place the magnets on the vehicle and on the track, and how you will arrange the poles of the magnets. Make sure to create 2 ideas in the boxes below. Designing a maglev system engineering design process. Plan. Directions. In the box below, draw a diagram of your maglev system design. Be sure to show the track and vehicle. Don't forget to label the parts. With the materials list below, make sure you say how much of each material you will need. Contractor feedback form. Have classmates look at your diagram of your maglev system design and see if your maglev will work. They will play the role of the conductor and you will be the engineer. Please list the contractor's names and the engineer's names. 1. Does this design look like it will be successful? 2. If not, what do you think might be the problem? How do you suggest the engineers might fix this? Drawing a schematic diagram or a diagram of the switch connection point may help you show your ideas. 2. If not, what do you think might be the problem? How would you suggest the engineers might fix this? Draw your design ideas to help them. Designing a maglev system engineering design process. Create. 1. Did your maglev vehicle levitate above the track? 2. How many weights was your maglev system able to transport? 3. Did your maglev system transport the weights safely? How do you know? 4. What part or parts of your maglev system worked well? How do you know? 5. What part or parts of your system did not work well? How do you know? Designing a maglev system engineering design process. Improve. Directions. After you have tested your maglev transportation system design, answer the questions below. What part or parts of your maglev system design will you improve? 2. How will you improve each part?